Hey guys, today we're going to continue our lesson on trigonometry. First, we're going to look at how to find a missing angle measure, and then we're going to look at various word problems. So first of all, if you are trying to find a missing angle versus a missing side, like we did in the previous lesson, this would be how it would be written. If sine of theta is equal to x, remember that theta represents the variable of the angle, then sine, and then you see this little exponent of -1, that means the inverse. The inverse of sine of the ratio of the sides, which is x, is going to equal to the angle. So now this is important. We only use the inverse of a trigonometric function when you're looking for angle measures. And for these kinds of questions, you will need a scientific calculator. So I'm going to be using my calculator here that I have on my screen in order to complete this. Now, when you have your calculator, the most important thing, and I mentioned this in the previous lesson as well, is that you want to make sure that your mode here is set to degrees. So always double check. If you didn't change your mode from the previous time you used it, then it would already be in degrees. But just in case, you can always just double check. So in this particular question, we have here this triangle and we're given these two sides and we're trying to find this angle measure. The first thing that you would do is to write out what these sides are. Is it the opposite, the adjacent, the hypotenuse, etc. So what we see here is that this is the angle I'm trying to find. The side that is directly across it, this is the opposite side. The side that is directly across the 90 degrees, that's the hypotenuse, which I'm not given, so I'm not going to use the hypotenuse. That means that this 10 is the adjacent side. Then you have to think of what trigonometric function uses the opposite and adjacent side. So you can always write your SOHCAHTOA to figure that out. Opposite and adjacent, that would be tangent. So we would set up our equation like this. The tangent of theta, since your trigonometric functions are always attached to the angle, is going to equal to the opposite, so 11.9, over the adjacent, which is 10. To figure out the angle, basically what we need to do is we need to cancel out the tangent. Tangent and theta are attached. This is not multiplication or anything like that, which is the biggest mistake that I've seen over the years. In order to separate tangent and theta, you need to apply the inverse of tangent to the other side. So theta is going to equal to the inverse tangent of 11.9 over 10. And that's how you get the angle alone. So now I go to my calculator here, and I'm going to select the inverse tangent. Now, depending on your calculator, it may look different, but in general, most calculators have the sine, cosine, and tangent buttons that we see here. And right above it, you will see the inverse of those trigonometric functions. So see here we have sine inverse in blue, cosine inverse also in blue, and then the tangent inverse. In order to activate the inverse, since that's in blue, I need to press this second button. And then I press tangent, and you see how in the notation here, it has that little -1. So now I put 11.9 over 10, which is just division, close the parentheses and press enter. And we are given 49.958. Now we're going to round to the nearest degree, so that means that theta is 50 degrees. Let's try a couple more like this. Here we're trying to find angle A. So again, we're going to label what sides are given here. The side that is directly across, this is the opposite, which is not given. That means that the 6 is the adjacent. And the 9 is directly across from the right angle, so this is the hypotenuse. Now again, I'm going to write here SOHCAHTOA, so we can identify what trig function it is that we're using. Adjacent and hypotenuse uses cosine. So we would set this up as the cosine of theta is equal to the adjacent, which is 6, over the hypotenuse, which is 9. Now you can choose to simplify this fraction if you wanted to, but you don't necessarily need to, since the calculator is just going to do the work for us anyway. So that means that theta is going to equal to the inverse of cosine of 6 over 9. So now I go to my calculator, second cosine, so it activates the inverse, 6 over 9, which gives me 48.18. And again, we're going to round to the nearest degree. So that means that theta is equal to 48 degrees. Over here, we are given the opposite side and the hypotenuse. The trig function that uses the opposite and hypotenuse is sine. So we would set this up as the sine of theta is going to equal to the opposite, which is 4, over the hypotenuse, which is 5. Now to solve for theta, we apply the inverse. So theta is going to equal to the inverse sine of 4 over 5. Come here to my calculator, second sine, so that it activates the inverse, 4 over 5, close parentheses, press enter, and we get 53.13, which is going to equal to the nearest degree of 53 degrees. So that's how you would find the missing angle measure. Now let's look at how to read some word problems. Before we get into an actual word problem, we need to be able to distinguish between what's called the angle of elevation and the angle of depression. The angle of elevation is always measured from the ground up. It is the inward angle from a horizontal line and is always inside of the triangle. These are the kinds of problems that we are most familiar with up to this point. So we are given here, for example, this angle. We have a tree, we're probably standing over here. We want to figure out the angle of elevation to the top of the tree. And I mean, think about the word elevation, meaning up, right? So an angle of elevation would indicate that the angle is looking towards the top. So that's exactly what this is. Now the angle of depression, when you hear the word depression, you think down. So this represents the downward angle from a horizontal line. The angle of depression is always outside of the triangle, never inside. So we can see here that we have this given angle. And this is the angle of depression from the top here, and we have to think of our line of sight as going horizontally across. So the angle of depression would be the angle from that horizontal line to the triangle. So this would be x. Now, if I wanted to solve for this scenario, let's say to solve for x, if you think about geometry, I know that it's been a while since we've taken geometry, but basically, when you have two parallel lines, which would be this horizontal dashed line and the ground, and you have a transversal, which is a diagonal that cuts across those parallel lines, the alternate interior angles would be equal. Alternate interior means alternate sides of the transversal, but interior of those parallel lines. So this angle here, see how it's opposite sides of the transversal, the x is on the top of the transversal, here the x is on the bottom of the transversal, but they are both inside of those parallel lines. These angles here in geometry, we learn that they are congruent, meaning that they are equal in measure. So whatever your angle of depression is, that's actually going to equal to the angle of elevation from the bottom on the other side. So if I wanted to solve for what this angle is equal to, this is the opposite side, this is the adjacent side, so this means that we would use tangent. So the tangent of x is going to equal to the opposite, which is 150, over 220. To solve for x, we would apply the inverse tangent. So the inverse tangent of 150 over 220. So we would put this into our calculator. Second tangent 150 over 220. And we get 34.28, so approximately 34 degrees. So that's one way of being able to solve this problem. You can also solve this in another manner. Let's say you do not choose to use the relationship of the parallel lines and the transversal, and you're just going to work with this. Then you would need to keep in mind that this angle here, this is 90 minus x. Since both of these angles, if you add them together, will give you this corner, which is 90 degrees, since this is vertical and this is horizontal. When you put a vertical and a horizontal together, it forms 90 degrees. Then what we could do is solve for the angle here, this 90 minus x. We'll call that theta. So this would be tangent of theta, since the 220 would now be the opposite side and the 150 is now the adjacent side. So this would equal to 220 over the adjacent, which is 150. So theta is going to equal to the inverse tangent of 220 over 150. We put this into the calculator. So inverse tangent 220 over 150, and we get 56 degrees. But what we solved for is this interior angle of the triangle, and what we need is this x. So keep in mind that that interior angle is 90 minus x. So we would do 90 minus 56, which is equal to the angle of depression of 34 degrees. So you see how both ways here would give you the same angle. So it just depends on what you feel most comfortable in doing. Just remember that when you are using trigonometric functions and you're solving for a missing angle, you're solving for the angle inside of the triangle, not outside. So that's why we would go through that process. Now let's look at a sample word problem. A nursery plants a new tree and attaches a guy wire to help support the tree while its root takes hold. An 8-foot wire is attached to the tree to a stake on the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. Find the height of the connection point on the tree and round your answer to the nearest tenth of a foot. So here we have a diagram that represents that scenario. This is the guy wire, which is what's in black here. That's the 8-foot wire. We are trying to find the height at which the wire connects to the tree. So that's going to be the x. And then we are given the angle of elevation, which is always from the ground, which is 42 degrees. So right now I'm giving you a diagram, but eventually we're going to take these diagrams away so that you would need to be able to read this problem and draw your own diagram so you can determine what trig function it is that you're going to use. Here we're solving for x, which is the opposite side, and we are given the 8, which is the hypotenuse. So if this is opposite and hypotenuse, that means that we are going to use sine. So I'm going to set up my equation here as what we're familiar with. The sine of 42 degrees is going to equal to x over 8. So now I multiply 8 to both sides, and I get that x is equal to 8 times the sine of 42. So now I go to my calculator, I put 8 sine 42, enter, and I get 5.353, which it says here to round to the nearest tenth of a foot, so 1 decimal point. So that means that this is 5.4, and then our units, because you always want to make sure that you indicate units, would be feet. Let's look at another example. We have here that from the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. If the tower is 45 feet in height, how far is the partner from the base of the tower? Round your answer to the nearest foot. So this is what I'm trying to solve for here. That's the x. Here is the forest ranger. We're given the angle of depression. So remember that that is from the horizontal line of sight to the triangle. So we can do this particular problem in two ways. I'm going to show you both. I'm going to start off by using the relationship of alternate interior angles. So that means that this angle here would also be 40 degrees. So if I'm using the 40 degrees down here, that means that this is the opposite side and this is the adjacent side. Opposite and adjacent, that means that I would need to use tangent. So the tangent of 40 degrees is going to equal to opposite, which is 45, over x. To solve for x, I would have to multiply x to both sides. So I get x tangent of 40 is equal to 45. And then finally, to solve for x, I would divide the tangent of 40. So x is going to equal to 45 divided by the tangent of 40. So now that I have that set up, I can go to my calculator and do 45 divided by tangent of 40. And I get 53.62. And it says here to round to the nearest foot, so this would be about 54 feet. Now let's say I chose not to use this relationship. If I know that my angle of depression is 40 degrees, then this angle here, because these two would have to add up to 90, would have to be 50 degrees. So what I can do now is that this x is now the opposite side, and the 45 is now the adjacent side. So this would still be tangent, but it would just look a little bit different. Now we would get the tangent of 50 is going to equal to the opposite, which is x, over the adjacent, which is 45. To solve for x, we would just multiply 45 to both sides. So this method, in this particular case, is a little bit easier because now all I had to do was multiply rather than multiply and then divide. So you just save one step, but either way, whichever method you choose is fine. So we have that x is equal to 45 times the tangent of 50. So we will put 45 tangent 50, and I get the same answer of 53.6289, which is approximately 54 feet. So you have options. That's what I'm trying to say. Let's look at some more problems. Now for these, I'm giving you these word problems, but without a diagram. So now we have to be able to read the question and be able to draw the diagram so that we can figure out exactly what trig function it is that we're going to use. For part A, it says here, find the shadow cast by a 10-foot lamp post when the angle of elevation of the sun is 58 degrees. Round your answer to the nearest tenth of a foot. So let's think about what this is going to look like. We have our lamp post. This is my lamp post. That's 10 feet. A shadow lands on the ground. So here's the shadow, which is exactly what I'm trying to find. Find the shadow. So this would be x. The sun would be somewhere up here. So this is my triangle. It says that the angle of elevation of the sun is 58 degrees. Remember that the angle of elevation is always from the ground looking up. So that would be this angle here, 58 degrees, since we are looking up towards the sun. Once you have your triangle set up, now we know what we're going to use. This 10 foot here, this is the opposite side since it is across the 58. And the x is next to the 58, but not the diagonal, so this would be the adjacent. So that means that this is tangent. So I would use the tangent of 58 is going to equal to opposite over adjacent, so 10 over x. Multiply x to both sides. We get x tangent of 58 is equal to 10. So to solve for x, I'm going to divide by the tangent of 58. So now we're ready to put this into the calculator. X equals to tangent divided by, 10 divided by tangent of 58. I come here, I'm going to do 10 divided by tangent of 58, and that gives me 6.24. And it says here to round to the nearest tenth, so that's 1 decimal point. So X is going to equal to 6.2, and then our units here, which is feet. So that would be the length of the shadow. Let's look at this other one here. It says, a ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find the angle of depression the ladder makes with the wall. Round your answer to the nearest degree. So, okay, let's draw this out. We have a wall. We have a ladder leaning on the wall. So that's my ladder. And this is the ground. Here's the 90 degrees. Okay. So it says the foot of the ladder is 6 feet from the wall. This is the foot of the ladder, and it's 6 feet from the wall. So it's talking about the ground. The ladder reaches a height of 15 feet on the wall. So here's my ladder. This is the top of the ladder. So this is the height, 15. We want to find the angle of depression. So the angle of depression is outside of the triangle looking down. It's not going to be this angle because remember that the angle of depression is formed by that horizontal line of sight. So this is the angle of depression. And if I use my relationship of the transversal within parallel lines, that means that the angle of depression is going to equal to this angle of elevation. So I can use this angle now in order to solve for the angle of depression. So this side here, this 15, this is the opposite side. The 6 is the adjacent. So we're going to use tangent once more. So now the tangent of my angle, which is what I'm trying to find, so theta, is going to equal to 15 over 6, opposite over adjacent. So remember how to separate the angle, we have to apply the inverse. So this would be theta is equal to the inverse tangent of 15 over 6. So now I just go to my calculator. I'm going to select second tangent to activate the inverse, 15 over 6. Remember, we only use the inverse tangent when we're looking for a missing angle. We never use it any other time. And we get here 68.19, which it says to round to the nearest degree, so theta is going to equal to 68 degrees. And this would be my final answer. Now let's look at a challenge question. A radio station tower was built in 2 sections. From a point 87 feet from the base of the tower, the angle of elevation of the top of the first section is 25 degrees, and the angle of elevation of the top of the second section is 40 degrees. What is the height of the top section of the tower? And round your answer to the nearest foot. So we're looking for this piece here. This is X. Now in order to find X, we see this triangle that is formed, this little one here. But the problem is that this is not a 90-degree triangle. Otherwise, we would see the little box, or you would be able to tell if it forms like an L, but it doesn't anywhere. So I cannot use trig functions for this particular triangle. Instead, what we do have though is we have this larger triangle here and this smaller triangle here. So what we can do is we can find out what is the height of the entire thing using the big triangle. What is this missing height here, which is the little triangle, and then to find the remaining side, which is the X, we can subtract. So let's start off by doing that. So I'm going to start here with this large triangle. So I'm going to call this height here I'm going to call that y, just so I can distinguish between my variables. So we have that the ground is 87. We have this angle here, which is 40. So we're using this angle. That means that the y is the opposite side and the 87 is the adjacent. So that means that I would use tangent in order to figure out y. So tangent of my angle, which is 40, is going to equal to the opposite, which is y, over the adjacent, which is 87. Multiply 87 to both sides, and we get that y is equal to 87 times the tangent of 40. So let's get that number and set it aside. So 87 tangent of 40, and we get 73. So y is going to equal to 73 feet. Now we're going to use the little triangle. So we have this one here, this other one that's 90 degrees. Sorry, I can't draw straight lines. I'm going to call this height z. Again, I'm doing this because if I know this big height here and I subtract it from this little height here, that's going to give me the remaining height that I want, the x. So now let's figure out what this is. Now we're going to use this 25 degrees because that's the angle within this little triangle. Z is the opposite side because it is across from the 25. And now an 87 is still the adjacent side. So let's set this up. This is going to be the tangent, since it's opposite and adjacent again, of 25 is going to equal to the opposite, which is z, over 87. Multiply 87 to both sides, and we get that z is equal to 87 times the tangent of 25. So we're going to put that into the calculator. 87 tangent 25, and we get 40.56, which we're going to round to the nearest foot since that's what the answer wants it. That's how the answer was asked for, so 41 feet. Now that I have y and I have z, in order to figure out x, what I would have to do is that x is going to equal to my large height, which is the y, minus the small height, which is z. So x is going to equal to 73 minus 41. So let's subtract. And I get that x is equal to 32 feet. And that would be my final answer. And that's applications of trigonometry.